There are three forms of a quadratic equation. The first is standard form, the second is factored form, and the third is a format called vertex form. This video is going to focus specifically on vertex form and some of the key features and information that we can take away from vertex form. The template for vertex form takes on the format of y equals a multiplied by x minus h squared plus k. So the only letter that is staying consistent between all three forms of quadratic equations is the letter a, which is always located right at the front of the equation. A always tells us the direction of opening for our parabola. Recall that if the a value is positive, the parabola will open upward. If your a value is negative, the parabola will open downward. When the parabola opens up, it takes on a U-shaped curve. When the parabola opens down, it's basically the same shape, just turned upside down. So you have an upside down looking U curve. With the vertex form of a quadratic equation, we've got two brand new letters that we haven't seen before in any of the other two formats. Those letters are H and K. The letters H and K represent coordinates or components of the vertex, hence why it is called vertex form. The H value represents the x value of your vertex. Remember that your vertex is a coordinate point that has x and y values, so the H value represents the x value of the vertex. An important thing to take note of, however, about this H value is that whatever is written in the equation as your H value, you're always going to read and record that number as the opposite. So if, for instance, your equation had a positive 4 as the H value or in the H position, you would actually read that as being a negative 4. Similarly, if in the equation you see a negative 3 in the position of H, you're actually going to read that as being a positive 3. Finally, the K value corresponds to the Y value of the vertex. It is the second half of your vertex. Nothing to note here, nothing special about this K value. Whatever you see written in the position of your K value, that's going to correspond to the Y value of your vertex. So if you are to put these two numbers together, that is going to give you your vertex. So let's try an actual example where we're going to take a look at equations that are in the vertex format, and we're going to pick out those pieces of information. So we need to identify the direction of opening and identify the vertex for each of these equations. The first equation that we have here is y equals 1 over 4 multiplied by x minus 5 squared minus 2. So the first thing we need to identify is the direction of opening. Remember, the direction of opening is given by your a value, which is the number in the front of your equation, and we're just looking to see if that number is positive or negative. In this case, we have a positive 1 over 4. So because our value is positive, our parabola is going to open up. And remember, if your parabola opens up, it takes on this U-shaped curve. In order to identify our vertex, we need to specifically pay attention to our H and K values. So our H value is the value located inside the bracket, and our K value is the value located outside of the bracket. So remember our rule that if you are reading your H value, you need to read it as the opposite of what you are actually seeing. So when I look at my equation, visually, it looks like my H value is negative 5, but we're going to record it as the opposite. So we're not going to write down negative 5, but instead we're going to write down positive 5. So I'm just going to write that here in my box here, that H is equal to 5. The K value we're just going to write it exactly as we see it. So in the equation, our k value is this outside number here on the end, and it is written as -2. So we are going to record it as -2. So when you are stating your vertex as an answer, you're basically going to just combine your h value and your k value together. Remember, your h value represents the x value of the vertex. The k value represents the y value of your vertex. So as a final coordinate point, your vertex would be located at 5 and -2. In our second equation, we've got y equals -0.3 multiplied by x plus 7 squared plus 6. So to determine the direction of opening, we're going to start by looking at our a value, which is right here in the front of the equation, and we're going to pay specific attention to the sign. So we have a negative a value this time, a -0.3. So because the value of a is negative, our parabola is going to open down. And when a parabola opens down, it is an upside down U shape. Next, we're going to identify our vertex. And so we need to figure out our h value and our k value. So our h value is the value that's found inside the bracket, and our k value, again, is the number on the outside of that bracket or at the end of the equation. Remember that we're reading our h value as the opposite of what we see. So our h value is written in the equation as a +7, but we are going to record it as a -7. Our k value, we can write it exactly how we see it. So our k value is a +6, so I'm going to record it as a 6. So when we state our final vertex, we're just going to blend those two values together in a coordinate point, and our vertex will be located at -7 and 6. The final equation here is a little bit different. This equation is not in vertex form. In fact, it's actually in factored form. I can identify that it's in factored form because I see these two sets of brackets. So if the equation is in factored form, we can still identify the features that we're looking for, like the direction of opening and the vertex. It's just going to take a little bit of extra work. It's not going to be as easy as pulling it out of an equation that is in vertex form. So let's start with the direction of opening. Again, we're going to pay attention to the a value at the front of the equation. Now, we don't see a number, but remember in math, if you don't see a number, there's still a 1 there. But again, we're paying attention specifically to the sign of the a value. So this happens to be a -1 in the front of our equation. So because we're dealing with a negative a value, this parabola is going to open down. All right, now in order to find the vertex, we're going to have to first figure out what are the x-intercepts. So because this equation is nicely factored for us, what I can do is just take each of these factors and I'm going to set them equal to 0 in order to solve for my x-intercepts. So I have x plus 1, which I'm going to set equal to 0. And if I isolate for x, I'm going to get -1. And with my second factor of x minus 4, I'm going to set that equal to 0 and solve for x, which gives me 4. Now that we know our x-intercepts, we can go ahead and start calculating our vertex. With our x-intercepts, we can actually calculate the axis of symmetry. The formula for that is x equals s plus t divided by 2. Remember that the letters s and t represent your x-intercepts. So the numbers that we just calculated, I can go ahead and plug them into the formula in the positions of s and t. So -1 plus 4 is 3, divided by 2 is 1.5. So the x value of my vertex, half of my vertex, is located at x equals 1.5. To find the corresponding y value of my vertex, I need to take my value for my axis of symmetry and plug it back into the original equation. So I've gone ahead and recopied out the original equation. And now everywhere I see the letter x, I'm going to replace it with 1.5. So we've got y equals negative. In the first bracket, 1.5 plus 1 is 2.5. And in the second bracket, 1.5 minus 4 is negative 2.5. And then it's just a simple multiplication. So we've got negative 1 multiplied by 2.5, which is negative 2.5, and negative 2.5 multiplied by another negative 2.5. That's going to give us an answer of positive 6.25. So if I were then to take my two numbers and put them together and blend them together into one coordinate point, my vertex would be located at 1.5 and 6.25. In our final example, we are given the graph for a particular quadratic equation, and we're asked to come up with the quadratic equation in vertex form, which models the graph that is given. So we know what vertex form looks like because we know what our template is. It is y equals a x minus h squared plus k. So we don't know what the a value is, and there's really no way of picking out the a value from the picture or from a picture of a graph. The one thing that we can identify very clearly, though, is the vertex. Now, because we have a parabola that is opening upwards, our vertex is going to be located right here at the bottom. So it is a minimum point that we're looking at. So our vertex is right here. And if I look at the scale and read the numbers off of the scale, my x value is going to be a 4, and the corresponding y value is going to be a negative 6. So my vertex, according to my given graph, is located at 4 and negative 6. Remember that the vertex corresponds to the letters h and k. So your x value of your vertex can be identified as h, and your y value of your vertex can be identified as k. So because we know the values for h and k, we can take these numbers and insert them into their correct positions in our vertex form template. So we're going to keep the y, we're going to keep the equal sign, we're going to keep the a, we open the bracket, we keep the x. Now, again, we need to be careful with the h value. So from what we picked off the graph, our h value we identified as being a positive 4. But remember, it's always got to be the opposite. So even now, when we take this value and insert it into its position in the template, we need to write it in as the opposite. So if we see a positive 4 as our vertex, we're going to write it as a minus 4 in the equation. Don't forget to square on the outside of your bracket, and then we're going to put in our k value. Our k value we've got listed as negative 6, so we are going to write it in the template as negative 6. So the only thing left to calculate or determine is the a value. The a value we can't pick out or identify from the graph. Now, the only way that we're going to be able to calculate this a value is if we fill in numbers in the place of x and y. Remember, you can only solve an equation for one variable at a time. So if I want to solve for a, I need to stick in some other numbers in the positions of x and y. Now remember, x and y represent coordinate points. So what we can do is go back to our given graph and pick out one other clearly identifiable point on this parabola. And you can pick any point that you want as long as you can clearly identify what the values are. Try to avoid picking a coordinate point that has a decimal number as its x or y values. It's just going to make the math messy, and you may not even be reading that decimal value accurately off of the graph. If I zoom in a little bit closer to my parabola, I see that there is a point that was marked for me with a blue dot. So I could choose to use this marked point, or if I really want to, I could pick my own point. I'm going to go ahead and use this marked point. Let's just keep it simple. So the coordinates of this blue marked point, if I read my scale, so the x value would be a 2, and the y value would be a 6. So I'm going to put that in here. This is 2 and 6. So remember, the first number represents an x value, the second number represents a y value. So now that I have numbers for x and y, I can go ahead and take these numbers and insert them back into my equation. So going back to my equation, in the place of y, I'm going to put in 6. I'm going to keep the a. In the place of x, I'm going to insert 2. And then I'm going to recopy out the rest. So now I'm going to go ahead and use algebra to solve for a. So if we follow the rules of BEDMAS, we need to solve what's inside the bracket first. So I'm going to recopy, and inside the bracket I have 2 minus 4, which is negative 2. That still needs to be squared, and we still have this minus 6. The next thing we're going to do is evaluate this exponent. So this is negative 2 to the power of 2. Negative 2 to the power of 2 is a positive 4. So now we need to be careful with how we write this. It does not make sense to do this. Keep the a in the front, the 4 in the back, and then minus 6. Because what ends up happening, and I can tell you from experience, is that students then subtract these two numbers. But you can't, because your 4 is still attached to your a. So instead, what we're going to do is we're going to evaluate negative 2 to the power of 2, which is 4, but we're going to write it like this: 4a minus 6. Remember, every time we write or combine numbers and variables, your number should be in front of your variable. So it's not going to be a4, it's actually should be written as 4a. So now this is a regular looking linear equation that we do know how to solve. So to begin with, I'm going to collect like terms. And so I'm going to take this negative 6 and I'm going to bring it over to the left-hand side. So that's going to leave me with 6 plus 6 equals 4a. 6 plus 6 is 12. And then to isolate for a, I'm going to divide both sides by 4. So 12 divided by 4 is 3, and so my a value is 3. The last thing we need to do, or to state our final answer, is to fill in the final equation that we solved for. So I'm going to again recopy the template for Vertex form, just to show you how to fill in or give your final equation. Okay, the only things that you need to fill in are your a value, your h value, and your k value. You don't need to fill in any numbers or information for x and y, because x and y really could be any number as long as it's on the parabola. So I'm then going to say, therefore, the final equation is y equals, my a value was 3, x minus 4 squared minus 6. And just as one final check, if you want to know if you got the correct answer for your a value, remember that the a value tells you the direction of opening. So we got a positive 3 as our a value. If your a value is positive, remember that means your parabola should be opening up. So if I go back and take a look at the parabola that was given to us, this parabola does in fact open up. So our a value matches the shape of our graph.